This is 8-33, letter A. It says, without graphing, determine where the graph of, It says, for each set of points given below, write a possible equation for a quadratic function in standard form. So I have to write an equation for these ordered pairs here. So something interesting about the ordered pairs is that you can see that the y coordinates are 0. So I know I'm not supposed to graph it, but I can't help but notice that it might go like this, or maybe it goes the other way. These, basically, because the y's are 0, I know that these are the intercepts. And if these are the intercepts, then that kind of tells me something about the equation of the graph. I know that I can kind of do this. I can go x Why can I do that? Because, well, if I go backwards, if I use zero product property, x plus 3 equals 0. So negative 3 must be one of my intercepts, right? I mean, if you go backwards. And same with this. So these are, now I can just FOIL these out and be done. So I don't usually FOIL, I usually use this area model. So this is x squared, 3x, negative 1/2 x, and negative 3/2. And then if I add those two together, I get x squared. I'm going to make that an improper in a minute here, but actually I'm not going to make it improper. I'm going to just multiply everything by 2, because it said I just need a possible equation. It didn't say what the stretch factor was going to be. I just need something that has these ordered pairs as my intercepts. So I'm just going to multiply everything by 2, and I'll have 2x squared. 2.5 times 2 is 5. And then 3/2. 3/2 is like 1.5. So 1.5 times 2 would be 3, right? So I'm getting that for my answer, and that actually works. You could have gotten a different answer. You could have left it more or less like this. You could have put any different stretch factor on it. I'm going to try to fit B, letter B, into this same video. So B has negative 3, 0, 2, 0, negative 3, positive 3, and negative 12. Okay, so these are x's and these are y's. I notice again right away that I know these are my intercepts. So I think I'm going to do kind of the same thing that I did in the last one, but then I'm going to try to find like a stretch factor. And I know it says don't graph it, but I can't help but just want to look at it real quick. 1, 2, 3, 1, 2. So this thing, it has a point at 3 and negative 12. I don't know, way down here. So I'm pretty sure it's a downward facing parabola. Not that I had to graph it or anything. I'm going to go ahead and do this though. This was x plus 3, and this was x minus 2. And we got x squared minus 2x, 3x, x squared plus x minus 6. Well, what would happen? No, that wouldn't be good. Let's see here. Let's go back. I think maybe I overdid it. Let's go right here and put an A. Okay, so this is kind of a difficult problem. So instead of me doing it this way, now if I plug in my numbers, then that's not going to work. So now I'm going to go ahead and, I'm recording. I'll be ready in a minute. Okay, so now I am going to plug in something for y and x. So let's plug in 3, negative 12. Um, 3. Okay, so this will be okay. So negative 12 equals a times 3 plus 3 is 6. 3 minus 2 is 1. So negative 12 equals 6a. So now I see that a equals negative 2. And that kind of makes sense because I thought it was a downward facing parabola. So now I'm going to go ahead and, gosh, I wonder if I can somehow use this that I already have. I already did all this hard work, so I think I can just go ahead and multiply this through by negative 2 since that's my stretch factor. Okay, so because I've already done this part where I've done all this work, so now I know a was negative 2, and I know what those two, when they get multiplied together, they make that. So now I'm just going to multiply everything by negative 2, and I'm going to have negative 2x squared minus 2x plus 12, and I think that will work.